All right, one more example of fully factoring. Always start by taking your given information and putting it into your final answer. So you were given that an actual factor is x plus 3, and so I know a solution from that factor is negative 3. Organize that given information. And now let's begin the synthetic or polynomial division. I'm once again going to continue using synthetic division, so I'm going to use the solution. I'm going to put my solution in a little box in the corner, then I'm going to line up the numbers I see. But remember, you need placeholders for anything that gets skipped. It goes from x to the third power, it skips x squared, and it skips regular x. So I need two placeholders since x squared and x got skipped. Let's complete the synthetic division. Bring down the 1. 1 times negative 3 is negative 3. 0 minus 3 is negative 3. Times negative 3 is 9. 0 plus 9 is 9. And 9 times negative 3 is negative 27. 27 minus 27 is 0. No remainder, which had to happen since I was using an actual factor and actual solution. I had to get a remainder of 0. So let's turn that into the quadratic. If it started with x to the third power, this is going to be x squared minus 3x plus 9. Now, like we mentioned in the last video, you have to try to factor this out. What's going to multiply to 9 and add or subtract to negative 3? If we think about it, you can use 9 and 1, but that's not going to help us get to negative 3. If you do 3 and 3, that's not going to help us get to negative 3 either. So what do we do when you can't seem to factor the quadratic? To actually prove that this quadratic is not factorable, and so we're going to call this prime, we have to use the discriminant, which is just the square root part of the quadratic formula. So we're going to come over here and do square root of b squared minus 4ac. When you're asked to find the discriminant, you just take this part and get one number. So my b value in this case is negative 3 minus 4 times a, which is 1, times c, which is 9. Negative 3 squared is negative 3 times negative 3, so it'll be positive 9. Negative 4 times 1 is negative 4, times 9 is negative 36. 9 minus 36 is going to be negative 27. Whenever you're left with a negative discriminant, we know this quadratic is prime, and we're going to get imaginary solutions. And remember, the second you can prove that a quadratic is prime, that needs to go into your final answer. So I'm going to go ahead and write down x squared minus 3x plus 9 into my final answer. Now I still need to get the solutions, and the only way to get solutions from a prime quadratic is the rest of the quadratic formula. So we're going to take what we just did and add negative b over 2a. So the discriminant already did most of the work for us. Now I need negative b, so negative 3 plus or minus 2 times a. So it'll be 2 times 1. And now we need to remember how to simplify this down. We'll El Chapo the negative 27 by first taking that negative 1 times 27. The negative 1 will give us our pair of i's. 27 goes into 9 times 3, and then 3 times 3. This is a square root problem, so I'm still just looking for pairs of factors. And so this is going to reduce down to the double negative will go to positive 3, plus or minus a 3 and an I escape. We're still left with 1, 3 without a partner, over 2. Your last step would be, is there a common factor with our escaped outside numbers? In this case, no, so I have my final answer here. And finally, don't forget to put that quadratic formula answer underneath the quadratic that it came from.